Now let's take a look at as well another interesting group of non-metals, which is the halogens. It's a group 7 or group 17 in the periodic table. All of these elements, they have 7 valence electrons, and they are considered to be the most reactive group of non-metals. In this case, the halogens are elements found from the second to the last group on the periodic table, and they are very reactive and they tend to form ionic compounds. That's something that we're going to study in more detail in the next units. And they need only one electron to be complete, so they react very easily with the group number one metals. So that's a very good combination for a chemical reaction, because you know that group number one, they tend to give one electron, and then this group number 7, they tend to receive one electron. So for these elements, let's take a look at some of the trends that we can see right here. As you go down the halogens group from fluorine to astatine, the elements become darker in color and have higher boiling point. And for the reference, we're gonna think like a fluorine is the most reactive of the halogens, is yellow. Chlorine is going to be kind of green. So these are the two gases. Then we're gonna just get into bromine, which is brown liquids, and then iodine, which is kind of a black purple solids. So these are some of the characteristics of those elements, but generally speaking, they are highly reactive and toxic. But they can be used as well because of their reactivity. They can be used for many other applications. Um, so here the reactivity decreases from the top to the bottom, and as you remember, we're not using really fluorine in the laboratory conditions, because this is a very dangerous a chemical that reacts very easily with anything, and even the manipulation would be very dangerous. And if we're exposed to this one for a long time, then we will probably die within minutes. Then chlorine as well, it's a very toxic gas as well, and usually what we use is chlorine products, chlorine compounds, and then that makes it more stable and less toxic. So all of these elements, they tend to gain one electron. So the easier they gain the electron, the more reactive they are. So that's why fluorine gains an electron very easily. So that's why it is more reactive than chlorine. Chlorine doesn't gain the electron as easily as fluorine, and so on. So that's why they gain these electrons. As well, these elements are not found free in nature due to their high reactivity, because as soon as they are formed, they react with something else. And in their elemental form, they are found as diatomic molecules. So whenever we have fluorine as an element, we have F2, or chlorine as an element, Cl2. And the same thing, when you're writing a chemical equation, you need to write the element as the element, you need to write it with the 2, because they only exist in nature as diatomic molecules, as these ones right here. Then something that it's important for us to know is the displacement power of the halogens when there is a chemical reaction, because some halogens are more reactive than some others. For example, in this case, we know that chlorine is more reactive than iodine, and then it kicks out iodide, in this case from potassium iodide, and then it releases into iodine, the element. And look at the pattern that we follow: is the element, then we have the halide or the salt, and if the free element is more reactive than this one right here, then it will kick it out, and then it will form the simple element right here, and then we're gonna see that the new halide is formed. This general pattern is very important for you to recognize, because there will be cases where you just have to complete the equation and eventually balance it. Remember, if it is more reactive, if the free element is more reactive than the one combined, then this element will kick out the one that is bonded, and will form the free element right here with the 2, and then it will form here the salt. That is the displacement reaction with the halogens. Then some of the uses that we have for this one, like fluorine is used in toothpaste to prevent tooth decay, but remember that not as the element fluorine because it would be very dangerous. It's as the ion fluoride. So we have fluoride salts and they're added to toothpaste. Chlorine is used as a disinfectant when added to drinking water. That is the most common disinfectant because it kills bacteria. Bromine also sometimes it is used as a disinfectant, but here we can see that it's used in some type of fire extinguishers that do not use water. And iodine is used in photographic chemicals to produce visible images, and also it is used as a topic disinfectant. So topic means that it's only used for the skin, and then it's used to as well to clean wounds and to prevent the growth of bacteria. Here, Clorox is precisely the name has some chlorine, and it's hypochlorous. And then a lot of plastics they have PVC, which is polyvinyl chlorides, which contain chlorine as well. Let's take a look at this question for understanding. So it says some properties of four elements P, Q, R, and S are shown in the table. Two of these elements are in group 1 of the periodic table and two are in group 7 in the periodic table. So let's take a look at this one. So we have element P reacts vigorously and it's a solid. So this is an indication that since it is a solid and reacts vigorously, it can only happen in group number 1 in the periodic table. Then Q, it says does not react with water and it's a solid. So this could be something like the only solids in the group number 7 is iodine. So this is basically iodine. Then it says that R reacts explosively and is a solid. So that means that R is also group number 1 in the periodic table, but it's below P because this is reacts vigorously and this one is explosively. So this has more reactivity. And then S dissolves, giving a color solution, liquid. So the only one that can do that it's a liquid, then it's bromine. And then that's what we have in group number 7. So which statement is correct? P is below R in group 1? No. We already know the opposite. Q is above R in the periodic table. So Q, it says it's a solid, so this is iodine and this is bromine, so this is not true because Q is lower in the periodic table. Then Q is below S in the periodic table in group 7 and also, okay, sorry, in B also it's not group number 1. Q is below S in the periodic table, so that's very likely to happen because iodine is below bromine. Then R is below S in the periodic table, so in group number 7. So we know that R is in group number 1, so it's not group number 7. So that's the answer for that.